proof by contradiction. So in this video, I'll explain what proof by contradiction is, how it works, and I'll also solve a couple of examples so that you guys can really understand what this proof method actually is. So proof by contradiction, you can use it to prove propositions and statements, and here's how it works. So let's say you have some statement P. So in a proof by contradiction, to prove that this statement P is true, you'll first assume that not P is true. In other words, you'll assume that the negation of statement P is true. For example, statement P might be root 2 is irrational. So in a proof by contradiction, you'll assume the opposite. You'll start with assuming that root 2 is rational. And using this assumption, you'll deduce a contradiction. And a contradiction is just anything absurd. For example, you might deduce that 0 is equal to 3, or that M is both even and odd. So you'll deduce a contradiction, and then you'll conclude that because we've deduced a contradiction, our assumption must be false. And because not P is false, it must be the case that P is true. So this is how proof by contradiction works. Now this is fairly abstract, so I'm going to give you guys an example so that you guys can understand this better. So let's look at an example. So consider this question. There is no integer that is both even and odd. Let's say you have to prove this statement. So you can use proof by contradiction. So this is what you will do. So first you'll assume that the negation of this statement is true. So the negation of this statement would be there is an integer. Let's call this integer n. There is an integer n such that n is both even and odd. You'll assume that this statement, the negation, is true. Let's just say assume true. And now we have to deduce a contradiction. So there is an integer n such that it is both even and odd. So because n is an even integer, we can write n as 2 times some integer p. Right, because all even integers can be written as 2 times the product of some other integer. And because n is odd, we can write n as 2 times q plus 1, where q is some integer. Because all odd integers can be written as 2 times q plus 1, and this is the general form of an odd integer. Now we can equate these two parts and write 2p is equal to 2q plus 1. And if we simplify this a bit, then we'll get 2p minus 2q equals 1. And we can simplify this to p minus q is equal to 1 over 2. Okay. Now, here we assumed that there exists an integer that is both even and odd. And that led us to another statement that p and q are 2 integers. Now we know that the difference between two integers, this difference is an integer itself. So if you subtract 2 integers, then the resultant number would also be an integer. But here we're getting 1 over 2, which is not an integer. So we know that p and q are 2 integers. And because p and q are 2 integers, we know that the difference between p minus q must be an integer as well. But here P minus Q is equal to 1 over 2. And 1 over 2 is obviously not an integer. So this is a contradiction. This is a contradiction. And because we've deduced a contradiction, we can conclude that our assumption, our starting assumption, must be false. So this assumption must be false. And because this assumption, yes. And because this assumption is false, our original statement must be true. So this is how proof by contradiction works. Now let's look at another example from set theory. Here's another example from set theory. So consider this statement. If E is a set with no elements, E is a set with no elements, and B is any set if E is any set, and then E, let's just write it here, then E is a subset of B. Now just a quick refresher on what a subset is. So if A is a subset of D, then that means all elements in A are in B. So if A contains the elements X, Y, and Z, then so does set D. So D also contains X, Y, and Z, and maybe some other elements, like, I don't know, 1, 2, 3, whatever. So this is what a subset is. So we have to prove this. Let me just erase this, yeah. So we have to prove this statement. And we can use proof by contradiction here as well. So this is how a proof would look like. First, we'll assume that the negation of this statement is true. So let's write the negation first. So the negation of this statement would be E is a set with no elements, and B is any set such that E is not a subset of B, right? We're writing the negation here. So we write the statement's negation. Let me just draw a line here to separate the question and the proof. Okay, and we assume that this negation is true, and then we deduce a contradiction. Okay, let's deduce a contradiction now. So E is a set with no elements, and B is any set such that E is not a subset of B. Now, saying that E is not a subset of B is the same as saying there is an element. It's the same as saying that there is an element in E that is not in B, right? So there is an element in E that is not in B. But here in our assumption, we assume that E is a set with no elements, right? But here we're saying that there is an element in E. Now, of course, E can't be empty. E cannot have elements and not have some elements at the same time, right? It's either empty or it's not. So we've deduced a contradiction here. The contradiction being that E is a set with no elements and that there is an element in E. So because we've deduced a contradiction, we can conclude that our assumption, that the assumption that we started with, this assumption must be false. This assumption must be false. And because this assumption is false, our original statement, if E is a set with no elements, this entire statement must be true. And this ends our proof by contradiction. So that's it for proof by contradiction. Don't memorize what a proof by contradiction is. Try to understand how it works and logic behind proof of contradiction, and it'll come naturally to you. So thanks for watching, and let me know if you guys have any questions. I'll try to answer them as quickly as possible.